Well, hello everybody, and welcome to another Vectric live event here on YouTube, on our YouTube channel. As you can see, not much has changed since the last time we were here in January. We're still working from home, unfortunately, but luckily the rain stopped, which was nice. It was drizzling a minute ago there, which is kind of good. So that's on our side. But like I said, we're still at home. We're still in lockdown over here in the UK. Hopefully on February the 22nd, Boris Johnson is going to lay out his roadmap and give us some sense of when this might stop, and maybe when we get our kids back to school again and we can start getting out and trying to foster a regular life again like we used to have, or whatever that's going to look like. Right now in the UK, our vaccination program is doing really, really well. We have vaccinated over 15 million people. And that's thanks to the NHS, obviously, and lots of volunteers that we are really super thankful for, and have really worked really hard so that we're getting protected over here, which is really quite nice. So I guess that's a bit of an update from me. Again, like I mentioned, we're working from home, so again, you never know what's going to happen. I got a train out back that goes by every so often that could be a bit noisy. The kids are at home, my wife's at home. Puppies at home, all that kind of stuff is going on. So you just never know what might happen. But hopefully everything will go as planned today. I'm really excited with this one, I have to tell you. So I got to stop being so giddy about it. I'm pretty excited. So right now we have, as always, we have Becky in the chat room to answer any questions that you might have that come up. And if she doesn't get to them, then of course at the end of the event, if you want to pop them in the chat below, we will we'll see them and we'll read them and we'll get you an answer, okay, as soon as possible. But also, and you probably already noticed this, we also have Mark Lindsay in our chat room as well, which is pretty amazing. He's going to have a little guest appearance, not a little, a big guest appearance here on this event. And if you don't know Mark, he's got a great YouTube channel where he does videos about different features of our software, and he has a very meticulous way of talking about them and explaining them, and it's really good, especially from the new user point of view, or somebody who wants to have a nice slow-paced sort of teaching experience. He does a fantastic job of that, and you can see below I did a little screenshot there of some of his stuff. He does a question and answer live. I'm not sure what his schedule is for that, but I see them pop up quite often. And then he also does many videos and also some other stuff that I'm not going to ruin it for you, because you might want to go check out his channel, okay? Especially if you enjoy this. Don't go yet. Wait until after this and then pop over and subscribe to his channel. So we have been, over the next few months, we're going to have different influencers that we would think might have something to offer you guys come on and be guests. And so Mark is our first one, and he was gracious enough to take on a challenge, something he's never done before. And it's one of those things that when you've never done it before, then you're not quite sure how it's going to go. So he recorded it, and I'm going to play his video next, and then I'm going to come back and we'll chat a little bit about what Mark did and how it worked out, okay? So let's go ahead, and I'm going to jump right into Mark's demonstration in the software of this feature that he's never, or this thing that he's never tried before. Here we go.
Hey y'all, Mark Lindsay from Mark Lindsay CNC here. Before I start, I'd like to thank Todd, Stephanie, and the whole crew at Vectric for inviting me to join in on this adventure. In this video, I'm going to do a couple of things I have never done before. The first one being, I'm going to create and carve my first VCarve inlay. Second, if you follow me at all, you know that I don't like to make a video on a tool, method, or technique that I've not used or done before and feel comfortable with. Well, Todd has convinced me that there is some value to you in me attempting my first inlay and letting you join in that adventure, and we both learn together. So, with that being said, I have some simple vectors here. I've decided to do a simple compass rose And I'm not going to show you how I drew these vectors. That's outside of the scope of this video. But suffice it to say that it's a couple of circles, 2 4-pointed stars, one of them rotated 45 degrees, and all of the vectors joined together. Now, this being for another project, instead of reinventing the wheel and drawing these vectors again, I'm going to just go ahead and copy these vectors and import them into the project we're going to work on today. So I'll select these vectors, right-click, and select Copy. Now, for creating a VCarve inlay, we'll have to create a female half and a male half. So I have 2 new sessions of Aspire started down here, and this one I have set up for my female portion of the inlay. So I'll come up here to the center, and I'll right-click, and I'll select Paste. And that pastes those vectors from the other project into this project. Now, the first thing I want to do is make sure that they are aligned to the center of the material. So with them selected, I'll just tap F9, and they are centered. The next thing I want to do is make sure that they're the correct size. Now, I want this compass rose to be 3.5 inches in diameter. So from this tip to this tip, I want to be 3.5 inches. And I know that these vectors are not 3.5 inches in diameter. So I'll come over to Set Selected Object Size and make sure I have Link XY checked and enter the correct measurement and click Apply. Now I can close that. For the female portion of the inlay, this is all I need to do. I'm ready to start toolpathing. Before I get into the toolpaths, however, let's briefly take a look at another diagram that I've drawn up in Aspire to show you how I'm going to come up with my flat depth and my start depths. The VCarve inlay process is rather straightforward, but there are a few numbers that most beginners, including myself, find it difficult at first to wrap our heads around. And that is flat depth and start depths for both the male and the female. Now, the female is fairly straightforward. It's very easy. It's a simple V-carve to a flat depth. How do we determine that flat depth? There are a number of things that will determine that flat depth. The first one being the thickness of the material you have available to make your male portion of the inlay. In my case, I've handicapped myself because the material I have for the male portion of my inlay is only 1/8 of an inch thick. So this has to be a pretty thin piece. The female is 3/4 of an inch thick, so this is not really an issue. I can go as deep as I want to here. Let me stop right here and point out these gaps down here and how the VCarve inlay process works. We make a simple V-carve to cut the female. Then we make a reverse V-carve to cut the male. The thing to remember is the only pieces of this inlay that are actually glued together are these angled surfaces here that are created by the V-bit. These are the only surfaces that actually make contact. These gaps here down on the bottom of the female and at the top over here on the sides serve 2 functions. Number 1, they provide clearance so that this surface of the male portion of the inlay and this surface of the male portion of the inlay do not make contact and interfere with this portion of the inlay seating itself fully within the female. So these gaps are created to keep these surfaces away from the female. They also serve a secondary function in that they're an escape route for excess glue. Glue being a liquid can't be compressed, so it has to have an escape route. It has to have somewhere to go. Otherwise, we won't get a snug fit. So, by having these gaps up here at the top, any glue up here close to the top surface will squeeze out in this direction, and any glue down here closer to the bottom will be squeezed down into this little well formed by these gaps. Where the confusion comes in is how to create these gaps and what measurements to use. Well, in my case, with the material for the male portion of my inlay only being 1/8 of an inch thick, I need to leave a little bit of material here so that I have something to clamp into the female when I go to clamp these together. So I have decided that a flat depth of 0.11 within the female will give me enough of an inlay surface that these surfaces here will make full contact, and there will be enough meat, if you will, to make it a secure inlay. And it'll still leave me enough material here on my male to clamp together. So that has determined the flat depth of my female, 0.11 inches. Now, how did I determine the width of my gap? Well, I didn't. Those who have gone before us in creating VCarve inlays have experimented with various gap widths here, and by mutual agreement, they all agree that 0.02 of a gap here and here is more than sufficient to allow the glue to squeeze out, yet keep the surfaces of the male portion of the inlay from interfering with making full contact on these angled portions of the inlay. So, from here, it's simple math. I want to use a flat depth on my female portion of 0.11. I want to keep a gap of 0.02. 11 minus 2 is 9. That means that I'm going to have 0.09 of an inch of material measured from the top surface down to the bottom of the male portion. That's how much material is actually going to be inlaid. So, 0.09 plus 0.02 is 0.11. This will become critical when we go to do the male portion of the inlay. For right now, in designing the female portion of the inlay, we only need to know our flat depth. So let's go back over to our female portion and let's start the tool path. For that, we'll select all of the vectors, go over to the Toolpath tab, and I'll do a simple V-carve. I want my start depth to be 0. So I'll set that to 0.0, and I want to carve to a flat depth of 0.11 of an inch. I'm going to use a 60-degree V-bit for this inlay. I want to use a standard bit that I know and that I've used before, and so I'm not learning a technique and a tool at the same time. I'm going to use clearance tools because I want to clear out as much of this inside here as possible. Now I have some large areas and I have some smaller areas. So for the large areas, just for speed, I'm going to use a 1/4 inch end mill. And if I select that end mill, I'm going to ramp in the plunge moves over a distance of a 1/2 inch just to make life easier on the bit and on the machine. For my 1/4 inch end mill, because it's going to come in and clean up the areas, it will enter in the area that it's already been cleared out and come along and do its cleanup process. So I don't need to worry about that. I'm going to come on down here and I'm going to name this VCarve female. And I'll calculate that toolpath. And we see that it's created 3 separate toolpaths. Clearance 1 uses the 1/4 inch end mill, Clear 2 uses the 1/8 inch end mill, and VCarve uses the 60-degree V-bit. I can now preview these toolpaths. We'll start with clearance 1. And we see what it clears out. I'll come down and preview the 1/8 inch end mill toolpath, and that cleared out a bit more. Then we'll come in with the VCarve toolpath, preview it, and we can kind of rock this back and take a look at it. And we see that we have our deep V out here in this area, and we have some cusps left behind by the V-bit. Now, I could tighten up the step over to reduce the height of these cusps, but I think we're going to be okay with this. Before I glue anything together, I will dry fit, and if it appears that I'm making contact down here, I can come along and clean these up with a small file or emery board or even a pocket knife, because this down here is not critical. It will never be seen. So we can go ahead and back out of there, and believe it or not, I'm ready to save G-code for the female portion of this inlay. So we'll go ahead and we'll close my preview window, and I have my VCarve female toolpath selected. I'll come up here to Save Toolpath. I have selected toolpath checked up here, and I want to look in my list and make sure that I've got the correct toolpath listed. I have my post processor set. Now I'll save this toolpath, and I already have my flash drive in my computer. I've made the correct folder, and I have folders for male and female, because this will require separate G-code files. So, go into my female folder, and I will name this 60-degree V-bit VCarve female, and I'll save that G-code. Then I'll select my 1/8 inch end mill toolpath, make sure I have it listed up here, save in that same folder, and I'll put 125 end mill. That identifies the tool for me, and I'll save that toolpath. Then I'll come up and select my 1/4 inch end mill toolpath, make sure it's listed up here, save, and I'll type 25 end mill VCarve female clear 1. And we'll save that G-code. So, I have my G-code saved. Now I need to save the file. So I'll come up to the File menu, Save As, and I'll go ahead and save it in the same folder. I'll put compass, rose, female, and save my file. Now I can come out of the toolpath tab, come back to my 2D view, and much like I did before, I want to copy these vectors and use these vectors for the male half of this inlay. So I'll select all the vectors, right-click, select Copy, come down to a new session of Aspire that I have set up to be the male portion of the inlay. Right-click, paste. And again, the first thing I want to do is hit F9 on my keyboard to make sure it is centered, and it is. I want to check my object size. It is correct. And now this next operation is critical. Even though this is a symmetrical design and the left and right should be identical, there may be a slight difference. So I want to reverse this image. I want to mirror it horizontally. That way, when we go to fit together the two parts, I'm assured that if there's any kind of a difference over here in a corner somewhere, those differences are on the same side when we go to make these pieces together. So I'll come over here to Mirror Objects. I want to flip about the job center. I do not want to create a mirrored copy. I want to flip these vectors here. And I'll click Flip Horizontal. Now we saw a slight difference. There was a little bit of a shift out here. But now I'm certain that any differences that are on the left side of the female are also going to be on the left side of the male when we mate them together. So I'll close that, and I cannot overemphasize how crucial that is. No matter how symmetrical your vectors are, flip them horizontally when you go to create your male portion of your inlay. So now let's take a look at what we're working with here. I'm going to bring up that diagram again. To create our female portion of the inlay, we did a simple interior V-carve, meaning we carved away the compass rose. To do the male portion, we're going to do a reverse V-carve, meaning we're going to carve away all the rest of the material and leave that compass rose. So in order to do that, what we need to do over here is create a vector boundary. We'll select that vector boundary and we'll select the compass rose, and the software knows to mill away, machine away all of the material around and within the compass rose. So, to create that vector boundary, the easiest way I've discovered is to create a simple rectangle. And I'll show you a little trick here. My material is 4 inches square. Well, when I want to create a rectangle that's the same size as the material, I'll select my anchor point, which will be the center of the rectangle, and my X and Y 0. Regardless of what's in these boxes here, if I want to make it the same width as my material, I'll highlight whatever is in there, and I'll type X and tap the equals button. Down here, I'll type Y and tap the equals button. That takes the measurements I have entered in Job Setup and puts that X dimension here and the Y dimension here. Now I know that I'll be creating a rectangle that's the same size as my material. I'll click Create, and it doesn't look like anything has happened. If I close this, come out here and select, we can see I have a vector the same size as my material around the material. So now I'm ready to start toolpathing the male portion of this inlay. So I'll select all of the vectors, come over to the Toolpath tab, and again, we're doing a simple VCarve toolpath. I'll select that, and now is when we need to look at the numbers we have written down, our start depth and our flat depth. That being these numbers here. The gap that we want to create here of 0.02 is going to be our flat depth, meaning with a start depth of 0.09, when we hit cycle start, the bit is going to come over and it's going to plunge in that 0.09 and start from there, then go the additional 0.02 to cut that 0.11. This 0.02 flat depth is the thickness of this gap. Let's go back over to our male inlay, and we'll put that information in up here. Our start depth is 0.09. Our flat depth is 0.02. I'm using the same 60-degree V-bit, and this is crucial as well. Regardless of which bit you use to cut your female, use the exact same bit to cut the male. Measurements of V-bits are nominal. This says 60-degree V-bit. The bit I select outside in the shop may be 59.5 degrees. It may be 58, it may be 62. To eliminate any possibility of an error, it is crucial that you use the same bit to cut both the female and the male. So I'm using the 60-degree V-bit here, and I'm going to use the same 1/4-inch end mill for this clearance pass, and the same 1/8-inch end mill for this clearance pass. We'll call this VCarve male, and we'll calculate this toolpath. And it's rather busy because we're machining away the outside of the material here. So we'll go ahead and uncheck that, and I'll select the first clearance pass. We'll preview it now. And with our first toolpath complete, we can kind of rock this back and take a look. Now, for those of you who have been wondering, this is why I selected the 1/4-inch end mill. Not only is it going to clear away the majority of the material, but it being the most robust bit of the arsenal here in this project, it's going to do the lion's share of the work, meaning it's going to take care of most of this material and make it easier on the 1/8-inch end mill and the V-bit. Because now the 1/8-inch end mill only has a few little corners here to clean up, and the V-bit will be more than capable of handling the rest. So that's the reason I chose that 1/4-inch end mill, was to mill away the majority of the material to make life easier on these other two bits. So let's go back to a straight Z view, and we'll preview our 1/8-inch toolpath, which isn't much really. It's basically cleaning up these radii. And we'll preview that toolpath. And we can see that didn't take long at all. Now we'll go ahead and do our VCarve toolpath. and that has come along and basically just added these angles. Now, something to pay attention to is if we look at this preview, and I'll compare it to our female preview in just a second, we can see that we've got these flat areas here. It does not come to a sharp point. It does out in this direction here, and that's fine. That's what we want. But the center section here and the bottom of this ring and where it meets this point of the star are all nice and flat. When we compare that to the preview of our female, we can see that the V-carved circles here, we have that sharp angle. That lets us know that we have clearance out around here. The male is not going to bottom out down in our V-carving here. Again, these are fine right here. But we want to make sure that we have this clearance down here for glue to escape when we go to clamp these together. So, this is looking good. Yes, there are, again, a few cusps here in the corners where the V-bit cleaned up. But again, should we need to, we can come in and kind of clean up these cusps if we feel that it's interfering with a good tight fit of the male into the female. So, with this portion done, we can go ahead and save G-code for the male half of our inlay. We'll go ahead over to the Save Toolpath form. And again, I've got my VCarve with the 60-degree V-bit toolpath selected. It's listed up here. My post-processor has not changed, nor will it. And I'll click Save Toolpath. And now I'll need to navigate to the correct folder. We're working on the male now. And I will name this 60-degree V-bit VCarve male. Save that G-code. Then I'll select my 1/8 inch end mill toolpath. Click Save Toolpath. And this is 125 end mill VCarve male clearance 2. We'll save that G-code. Then I'll select my 1/4 inch end mill. Make sure it's listed up here. Save toolpath. And I'll call it 0.25 end mill VCarve male clearance 1. Save that G-code. Now I'm ready to go outside and carve my first VCarve inlay. No, I'm not. Todd, help!
Mark, that was really good. Thank you for that. You did a fantastic job explaining all about how to create your first inlay, and you did a great job, like I said, explaining everything. So, full disclosure here, that was Mark's first inlay, and you can see my first inlay over there ever. So this is my second inlay that we're going to be working on, and I'm going to be using Mark's files to actually cut the sample that he would have cut on his CNC if he wasn't in the middle of a huge renovation project, which I'm really excited to see how it turns out for him. So, like I said, the first one I ever made is up here in the corner. It's a pencil box that you can download for free, from your V&Co account. And in that actual file, or the package of files you get, there is this cheat sheet, which is a lot like what Mark showed you in his video, and it describes how the parts interact with each other, how you need to create the male part and the female parts, and how the flat depths and so on work. And you can see here, like Mark had pointed out, that you want it to marry up nice and tight so that your sides of the V carving, that taper, actually are the parts that rest together nice and tight. So you end up, so when you end up surfacing off the top of it, you don't have any weird gaps and so on in there. So if you're a first timer at doing VCarve inlays, then definitely I'd suggest you go download that particular project, the pencil box, and take that PDF out and keep that nearby, because there's a little bit of formulas and stuff there and so on. It really helped me with my first inlay. So again, thank you, Mark, very much. So what I'm going to do now is I'm going to do what I think that I would do, which I am going to do, but I would do if I was going to download a free project from Vectric, or I was going to get one from a client or from a person like Mark, and actually bring it into the software and take a look at how I would change it up, or what I would look for so that I could make it safe for my machine and the materials that I'm using. Okay, so let's go ahead and have a look at Mark's file. So this is Mark's file. He kindly sent it to me to share with everybody. And as always, you get this warning that pops up. Make sure that you read and understand this. It is really, really important that you do that. And that will come in a bit later when we talk about different ways of cutting this and tooling it up. But make sure that all your tool paths have been adjusted and are safe and appropriate for your machine, the wood you're working with, and the tools that you have on hand. So I'm just going to click OK. So to start with, the first thing you should do every time you download a file from us is you should take a look at the job setup. So let's go ahead and take a look at that. Now, I know Mark just went over that, but we're going to pretend that we didn't see that video, okay? So let's have a look at the job setup. We know it's a single-sided job. These are the dimensions that he outlined for his material and his setup. He's zeroing off our material surface. His datum is set to the center. Now we're not going to adjust this right now. We're just going to check it over so we understand how his file is set up. We are going to look at, he uses the standard or fastest setting, which there's no 3D content in here, so that's perfectly fine. And then a solid color for his material, which is great. And instead of clicking OK, we're going to hit cancel. We don't want any recalculation of tooling. We just want to go ahead and press cancel. Take a look at the layers, of course. There's only one layer. That's perfect. That's exactly what we want. And then we can have a look at his tool paths. Now, I'd forget to tell you that we're only going to take a look at the female part of Mark's job, because everything we're going to look at is kind of the same. Like you said, you're going to mirror back and forth your tools, so it shouldn't be that much of a challenge for you in the end. But again, when you're downloading one of these from us, you should take a look at these files inside and out. So let's go ahead now and check his material setup and make sure it's exactly what we expect to have happen. The thickness of the material, again, the datum set to the center. Zeroing off the surface, and we also have our model position is right at the very top of our material. Quite often this isn't the case when you're looking at 3D content, so make sure that if you're using 3D content you are checking to make sure that the model is where you want it to be. There is no model, so we're just going to work off the top of our material here. And then again, these settings here are what are safe and appropriate for his machine. So we're going to have to change these. You're going to have to change these when it comes around to you actually recalculating the tool paths and saving those out. Okay, so I'm going to cancel that. And then we can take a quick look at his tool path. Now, like he said, this is a V-carving tool path using the clearance tools in there to help clear out some of that material that we don't want to waste the time with cutting with our V-bit, which could be quite timely, right? Because it's quite a small step over. So you're going to want to use, well, we want to be able to take advantage of this particular feature. So again, we have our start depth, our flat depth with Mark explained, and again in that file, that PDF that I showed you, you can get a little better, another explanation of how that's done. He uses his V-bit 60 degrees, like he said. He's got his two clearance tools, and everything looks great here. So we can go ahead and click close, and then one at a time, we're going to go through and preview those tool paths, okay? So that we know exactly what's going to happen when we go ahead and adjust these for our own machine. So let's have a look at the first tool path. We're going to preview that selected tool path. Here we are. So we know what's going to happen. It's going to do that big clearance with that 1/4 inch end mill for us. Let's have a look at the other one. So it's going to do those little bits in there with the 1/8 inch end mill. And then we're going to go ahead and have a look at the, oh, sorry about that. We're going to have a look at the V-carving bit. Anyway, there we are. So that's exactly what he expected to have happen. It looks great. As he pointed out, you got these nice flat areas, which are important. I'll point those out again a little bit later, but they are there for you so that you're actually going to bottom out and there'll be a bit of a gap in there, which is great. Now what I suggest you do is take this file and save it off. save it under a new name. Maybe it's Todd's Edit or whatever happened. Well, use your name, not mine. And go ahead and save that off. And then you can go ahead and mess around with that one. And you always have the original one that we provided for you, or in this case, Mark provided for you, to go ahead and muck around with, okay? So that's pretty much it, what I'd expect you to do with what, when you get a file from us. Going in and changing all those things is pretty easy. You can go ahead and take a look at the actual job setup, make your adjustments that you want. Okay, if I want to go ahead and move my datum to the bottom left, which is great. Maybe I want to use Canadian maple, because you would, right? That's right, eh? And then you go ahead and click OK, and it's going to ask us to recalculate all our toolpaths. You can just say OK, and they're all recalculated. We're going to go over to our material setup, and again, make sure that you change all of these settings down here so they're safe and appropriate for your machine, and then click OK. And then you can go ahead and pop into these tool paths and change up the tools that you want by selecting tools out of your tool database that match up. Now, because you've got two files, right? You've got your file and his file. When you go ahead and preview your tool paths, you can actually have two instances of VCarve or Aspire, whichever you happen to have open, and you can have a look at them side by side and make sure you're going to get exactly what you expect to have happen just with your own tool setup, okay? So that's pretty much it. And what you could do is go into the other, the male file, the female file, excuse me, and change it up if you want to, okay? So now, I took those files after I had edited them up and took them into the labs, and I quickly cut at the end of a day the files. And so here you can see this is the female portion of the inlay, cut like a treat, and it's perfect, no problems at all. You can see a little bit of a plateau in the center of the star, and but that's probably because either my material wasn't flat when I zeroed my tool, or our zero plate's a little bit wonky, so maybe I didn't quite get it flat like it's supposed to be. So there's a little bit there in the bottom, but overall, I think it's a really nice cut and it worked really well. I did have to go in with a knife, like Mark said, and pop out some of the leftover material there from the V-bit, but that wasn't any big deal. I used a little bit of sandpaper and sanded that out, and that was great. So that worked out really well. Not so much the case with my male part. This is not a problem with the tooling at all. And so when I had a look at this, you'll see the little video will play up there.
The female part turned out really well.
Cutting it.
No problems at all.
There's some chipping going on. Seems to be where there's
though,
thin areas and they run against the grain or with the grain.
Not so much. It kind of chipped,
it was a real problem. I did have the flat area on the top like I expected,
the grain,
which was
I guess
great.
you'd call it.
And
kind of chipped a bit.
I wasn't quite sure what to do next. Like I
down
said, at the end of the day, it was
my
kind of
cutter
wasn't the best
being
time
a
to
bit
have
dull.
this happen. But one of the bonuses, or one of the good things that did come from this,
So I think
is
what
that
I'm gonna
I could
do
test
is a
fit
couple
the
things.
male part
I am
into the
going-
female
oh, yes,
part.
first of all, next of all,
and it
actually
perfectly,
fits,
which was great. So I knew that at least
nice
the
and
math
snug.
was
It
great.
doesn't
If I held it
move
up on
at
its
all.
edge, I could see there was
So
a teeny bit of a
the
gap
math
in
and
there.
everything works
So
out
all of that
perfect.
was
It's just the
working
material
out fine.
and the
So I
cutting
left for the
runs.
day, came
So,
home, sent Mark an
what I'll
email.
do
Him and I
is
had a little
I'm
back
going
and
to
forth
go
about
back
this little
to
problem,
the file,
and we
I
came
might
up with some
actually
ideas
fill
that
at the
I could
ends of
try.
these,
So I went
and I
back
might
in,
actually that
to
way
bunch
at the
those
point it won't
ideas,
feel pointy,
feed rate,
and
changing
that
my
might
feed
actually
rate,
hold it together a bit
looking
better.
at the tool that I was
And we'll
using,
also go ahead
and
and
all those things and different variations seem to make things better. Sometimes
I'll
didn't,
switch the
sometimes did.
blade
Let me tell you,
on
this is a
our
complete art
V-bit
form. If
before
you
I
do
cut it
this
this time,
for
okay?
a living, then
But
you're going to
overall, it
nail
looks
this
pretty
every
good.
time.
And maybe it's just
But
the
the build up
material.
to
I just
doing
need
your
to find a
second one
different-
or your first one,
In the end, I think I might be using a different material
then,
anyway for the inlay. I think
you know,
it'll be
there is
more
a
like
little bit of fiddling you got to do,
this
but I was
here.
lucky enough to have the time
That
to
might
actually
actually
cut
be
these
a
samples.
bit
Now,
better.
even the
A
ones
tighter
in the
green,
white
maybe.
Corian
I don't know.
chipped on.
Anyway, we'll see. Anyway, Mark,
very end
there
of
you
the
go.
day-
It worked. I just need to get some better material and a sharper cutter, I think. Excellent, man. Thanks so much. Bye-bye.
Well, I seem to have let me just see here if I can.
Okay, Mark. Here we go. So
have
the
two
female part
voices,
turned
I
out
think,
really
coming
well.
up here. So let me just go ahead
No
and
problems
turn
at all. Cut really easy. The male part, though, on the other hand, not so much. It kind of chipped, especially when the thin parts were running against the grain.
There we go. Sorry, I had the video playing in the background. I apologize. So anyway, let's get back there. So that was Mark, and that was me sending my email off to Mark. So there you go. You get a chance to hear that in the background with me talking over. Let's just go back a few steps, okay? Just so that I can redo all that again. So like I said, the male part didn't work as well as I thought it was supposed to. So I went and talked to Mark a little bit, and I sent him a little bit of a video off, and I came back with some of our ideas that I thought would help, including feed rate changes. My bit may not have been perfect, might have been dull and so on, or could have been chipped, who knows. And at the end of the day, I was getting very frustrated with this. And I ended up doing something that I didn't imagine would actually work at all, but it did. I actually reversed the order of the way I ran the tool paths. So I did my V-carving first, then the 2 clearance passes, and that seemed to fix things up, as you can see in this version here. This is done in Korean. It worked exactly like what I expected. It actually has the flat tops like I wanted to, or at least what I thought were right anyway, and I could go ahead now and finish up my inlay project. So, knowing all of that, I decided I didn't want to waste this beautiful inlay job that Mark had done and that we had worked so hard to get sorted out. And I went and came up with a finished project. I thought it'd be nice to make a little snack tray with a coaster to hold a drink and maybe a place to add, some chips or crisps or whatever you happen to have in there. So I did that, and now I want to show you just briefly what I did and how I did it to get to the point of a nice snack tray. Now, up until now, you can cut Mark's files in VCarve Desktop or VCarve Pro without any problems at all. You haven't used any Aspire features whatsoever. So, but in this next bit, I am going to take it into Aspire, and we're going to do some of those things. We're going to use one Aspire only feature, and then I'm going to show you something that you need to remember when you're doing this to make sure that you actually get everything landing where you expect it to be, okay? So let's go ahead and flip over to my software. So here again, we have this little notice here that says to check all of our tooling and make sure it's safe and appropriate for your machine, okay? Please make sure you read that and understand it and change all the tooling like I showed you a few minutes ago on how to do that, walk you through that. And this is my finished file, okay? So what I did was I took in Mark's star, and I loaded up his file. Actually, I used his original file and his tooling, the one that I had changed up and so on. I just made a larger job space and created this job here, which is, like I said, a little bit of a snack tray. If you take a look at my job size, it's 9 by 5.5. Oh, let me just move myself out of the way here so you can see it better. 9 by 5.5, and the thickness is 0.97 of an inch. I knew the material that I had was pretty thick, and so I wanted to use that. We're going to zero off my material surface, change the start point to the bottom left. I chose very high. It's hard to teach an old dog new tricks because I use 3D content a lot. It makes sense to do that, but it could be, I could have chosen to use the standard if I wanted to without any problems, and then Canadian maple. Okay, if we take a look at the actual layers that we have, we've got the inlay, the borders, and the drink and snack trays. So if we turn these all off, we've got Mark's inlay, which I copy and pasted in. We've got the border. I'll talk about that border in a second. And then we actually have the actual drink tray vectors in the end. Okay, and then we have our tool pads. So one of the things I did do, one of the things I decided I was going to do when I was having all those issues with me and not Mark's file, I decided that I would go in and actually fillet the ends of all of these really sharp points. So I filleted those 0.0156 of an inch. And I chose that number only because it looked good in the end. There was no particular reason why I did that. I used our fillet tool. I went in and I just filleted the end of those really quickly. And all of these sharp points, and that seemed to help out a lot. So that's the first thing I want to point out to you, the actual edit of Mark's work. Again, I can use this vectors. I can copy these out like he did into my male part file and have those ready to use exactly as they are. Make sure I flip them and all that kind of stuff like he had showed you. This line out here is going to be the border that I'm going to use to cut the actual male insert that I'm going to use. I had to make sure that I had a vector there that's slightly smaller than the dish that I want to set it inside of. Okay? And if we look at the 3D view, you can see that I created these dishes that are here. Okay? Now, these aren't clip art dishes. These are actually created very simply with one of our shape editing tools built right into Aspire. So let me show you quickly how I did that. We'll go back to our 2D view for a second, go over to our modeling tab. I'm going to create a brand new level, and I'll hide this first level, and I'll make sure I have this selected, okay? If I go into my shape creation tool here, we have this new feature that came in with 10.5, and what it does is it creates a shape and it blends it to inner vectors. So we can have two different vectors, and we can blend this kind of S shape and create a flat bottom dish. And we can demonstrate that by choosing these two vectors. Okay, we've got that selected. We have no base height. We're going to blend to our inner vectors. That's the height of our inner vector. But in this case, it's not our height, it's our depth, because we're going to go ahead and we're going to subtract that. And if we click apply, you'll see that in our 3D view, we have a nice dish, and it's got that sort of S shape to it, which looks really good. Now, you'd think that's fine and dandy, Todd, that's perfect. I can just bring in a 3D component. I can make that shape without any problems at all, or I can use a 2-rail sweep. Go ahead and use a 2-rail sweep if you'd like to. That's a perfectly good feature to use, but this just makes it a little bit faster. Yes, you could use that 3D content, and if you have VCarve Desktop or Pro, then you could create this or a version of this using some 3D content, some dishes and so on, and you could do that as well. So that's perfect, but you certainly couldn't create this shape over here. So if I choose those two vectors again and go ahead and use my same settings and click apply, you'll see that now I have this other dish, and that's where I can put my peanuts, my cashews, or my chips if I'd like to, whatever it happens to be. Okay, so let's hide this and then go back to our original ones that we had here when we came in. So again, that's an Aspire only feature, and off we go. So I've got all the bits I need now to make my tray. I've got all the vectors I need, and I have all of the components I need. Let's move myself to the center here. See a little bit farther over maybe. And let's have a quick look at the tooling. So let's bring that out here and have a look. Now, I'm not going to go over all this tooling in particular because you should probably know how to do most of this, but what I've added to this is a roughing and a finishing pass, and those are based on these two regions here. Okay, so I'm going to use my roughing pass. I'm going to use a 1/4-inch end mill, get rid of all that stuff in there. I'm using my selected vectors, so I'm selecting these outside vectors here to go ahead and use that. No boundary offset. I don't want it to run up on top of the edge of this. Now, one thing I did notice that I forgot to do was I could have added in a 0 plane, and that would ensure that I didn't roll off the edge by mistake. With these particular tools that I'm using, they're too big and they're not going to roll off the edge, so I was pretty safe. But I think that standard practice would be you should actually put in a 0 plane in there. Okay, something if anybody noticed out there, it's not there. I'm leaving a little bit of a machining allowance behind, and I'm going to use Z-level roughing, which is great. And there's the name of the thing, and so I can go ahead and calculate that. And we'll just wait for it to work its magic. Then we can preview that visible toolpath, and that does exactly what I want it to do. That's great. Go in and I can go ahead and do the finishing pass. 1/4-inch ball nose, I'm using a really big ball nose end mill. Selected vectors again. There's no boundary offset. Again, I don't want to come outside of those shapes. I'm going to use offset tooling. I did that on purpose because I didn't mind if the any kind of machining lines look like they're radial. They kind of come to the middle. That would look kind of nice in this particular situation. And that's great. So offset tooling, and that's fine, and we'll calculate that up, and that all looks great. It'll take a second to do this. Now, I wanted that ball nose end mill in there because I wanted to make sure those round bits at the bottom and the tops of those dishes were kind of smooth at the top and bottom. So if we preview that, you'll see that we get those shapes that we wanted to. Now, the next thing I want to show you is important. These are the tool paths that I made and I cut my sample with. So I knew that they were going to work, except for I need to make sure that in this particular job, I get on the very bottom of this form and I project this onto my 3D model. If I don't do that, it will just go ahead and cut these at the top of my virtual material block, and there's nothing there. So I need to make sure that I project those onto the 3D model and then calculate that. And what you'll see is that they'll actually be lying on the bottom of that dish, which is where they should be. Okay? And I can go ahead now and I can close that, and we can preview those visible tool paths just like Mark had showed you. And there it is in the end. And then we have our last tool path here, which is going to be our cutout profile cut with our tabs in there. And we can just go ahead and preview that visible tool path. And there we have our tabs in the bottom. I didn't need to show you that because I'm sure you've all done profile tool paths before. It's pretty basic, and added in a couple tabs, and that's great. So that's perfect. So there we have it. That is actually my female part of my snack tray. So let's have a look at the male part. So again, make sure you read and understand all the information that's here. It's really important. And when I talk about this particular part of this project, that is very important. And I'll show you in a second. So here we have our job. It's exactly like Mark had said. Okay, I set it up. I copy and pasted those vectors in from my female part to make sure they were exactly the same. There is that that border vector that I talked to you before that we're going to use to actually create this round puck shape that's going to fit inside of our, that's going to be the base of our male inlay. So it'll fit inside the bottom of our dish shape that we've created. And let's have a look at the tool paths for this. Okay, again, it's exactly what Mark had suggested, except for, like I had said, I reversed them. I decided to calculate them, and for my own use, I actually shuffled them around. I put the V-carve first, and then I worked down to the 1/8 inch clearance tool and the 1/4 inch clearance tool, and then my cutout pass, okay? And there was no need to project this onto the 3D component because there was none there. I just cut it as I did before, which is no big deal. So let's go ahead and preview all those tool paths right quickly here, and you'll see what happens. And there we have the end result. And I had used double-sided tape to stick this to my table with, so I knew that it wouldn't move around and shuffle or shift. That was my plan anyway. It wouldn't move around any. So there we have that. And again, you're taking a look at that. It has all the parts that Mark had pointed out. It has a flat top here. It doesn't come to a sharp point, and so on. And everything worked out in the software. Everything looks perfect. Now, when I went to cut it, I ended up having a little bit of a problem, and that was my bit was broken, so it was chipped on the end. And I cut a couple of these, and I couldn't figure out why the male part had a very sharp top. And that was because I was using a shorter tool because the tip was broken, and that wasn't a great thing. And I noticed that right away on the parts that I created. And so we went back and we did a little searching around, and we figured out, we noticed that it was broken. I replaced the cutter out, and then everything was great. So knowing that tip certainly is, you can tell right off the bat when you cut your male part. Off you go. We're going to cut the male part first, then we're going to cut the female bits, so that way we can dry fit them together. And if anything is wrong, hopefully we can fix that. Okay, so let's go ahead and take those into the lab. Oh, I forgot one thing. I'm going to show you one more tool path that we didn't talk about, and that's the clearance tool path. This is the one you run after you've glued up your two parts, and you need to run and remove all of the base of your male part off. Okay, so again, make sure you read and understand all of the stuff here. It's important. And let's have a look at the tool paths for this. Okay, now you're going to see there are 3 tool paths here. The first one is me cutting this with an end mill. I'm just cutting the bottom or the back side of this off down to the base of my dish. So this dimension is from the top of my material down to the bottom of the dish, okay? Because when I glue in this puck, it doesn't rise above the top of it. Or if it does, I'm going to be zeroing off a different part of my material, so it doesn't matter. I'm going down that deep. I'm using an offset tool path for this first one. And any of you guys out there, or folks out there watching this, you know there's a problem with that. I'm cutting a circle from the inside and out, and there's nothing holding the edge of this in place in the end. And so there's a chance that it can break off and actually twirl around the end of the bit, which did happen. So that's why I am giving you another tool path here to look at, which is the raster tool path. Depending to surface this off. So depending on the shape of your puck, or the bottom part of your male inlay that you want to remove, you can use whichever one is fitting. Not unfortunately, but for this project, I had to try both because it kind of was a bit worrisome when I saw the first one go. And so you can see that this one here will preview that tooling right away. You see that's working from the inside out. So at this last pass, when it starts to and things start to disattach, then I get this sort of ring of material that's going to not be happy. So let's reset this, and we'll go ahead and try our raster back and forth. Smarter plan for this particular shape. which would have been great. And then there's this third tool path here. I created this as a little teeny step down in case I didn't zero the machine properly or something, and I needed to actually run a little tool path to remove a little bit of a skim. So there's an extra tool path there for that particular operation, which I didn't need to use anyway. So, but I had it available in case I needed it. So now let's go ahead and take a look at what happened in the labs when I cut these. Following all the safety stuff we need to in our labs, wearing the mask, using double-sided tape to stick down the Corian, marking the center point of that, and then putting in my first bit, which, as I said, is a V bit, cutting these in the reverse direction for my actual nail parts. That worked out. Corian, by the way, if you've never cut yet, it is really quite nice to cut. It's slick, it cuts really well and very cleanly, and you can see that I got a nice flat edge on the top of there like I expected after I put a nice sharp bit in there. Going in with the 1/8 inch, and as Mark pointed out, this is really quick. It only does the little bits in the corners that it needs to do. And then you swap in your 1/4 inch end mill and do the lion's share of the work here. Now the reason why I think that cutting the V-bit first with this is because cutting the V-bit first meant that I had some support to hold those sharp edges in before I went in and pocketed out all the other stuff or cleared out all the other stuff. Might be something you want to think about, something you can chat about in the comments and so on, whether or not you think that was why maybe I got chipping, but it did help, and you can see right there that reversing that. And it was a safe process, it didn't hurt anything. And here we did it in walnut as well. You notice that I screwed down the walnut and I also double-sided taped it down. Did that on purpose because the walnut was a bit bowed, so I put the convex part down on the table and I screwed it down to flatten it out. Just ran those same tool paths again, and everything seemed to work out okay in the end. Then you'll see there was very little chipping. There was some interesting folding of the material, but I think that was just, I didn't clean it up very well when I went to glue the two together in the end, but I think it worked out really well. There we go. And then the chipping that did happen was at the base of the V-carving, so it didn't matter anyway. That was in the inside of the actual inlay, so you didn't see it in the end. Now here we go off. We're actually going to cut the snack tray. Now we cut two of these. I wanted two different samples like you saw. I wanted to try the Corian out, and I wanted to try the wood out and see which one looked best and which one worked the best. This is the roughing pass with that end mill, 1/4 inch end mill. Worked out really, really well. Swapped in the ball nose end mill, and that was perfect. Went along and made sure I had a nice cusp at the bottom of my shapes that I created there. Standing safely behind our glass there to make sure everything is safe. Check that out, everything looked good. A little bit of pre-sanding before I went on to the next part. As Mark said, it's always good to sand before you take it off your wasteboard if you can. Went in, there's the 1/4 inch clearance, and comes the 1/8 inch clearance for the female part. And then we'll go in and swap out that bit for the B bit and do the last bit. And again, that looked really great. I did have to go in and do a little sanding in there, which you'll see in a minute, but that all worked out fine. The test fit, everything was perfect. Worked out really well. Nice and tight in there, and it didn't slide around. That was great. Let's go in now and do our profile cut. Get that ready to come out and off our machine so we can do some finishing. Use a little saw to remove it out of there, cut those tabs. And off to some sanding. So I did a little bit of pre-sanding, then we went over to the sanding machine, the belt sander, and we got rid of those tabs. More hand sanding to get those nice smooth edges that I wanted. And then I used some wood glue to glue in the wooden male part into the snack tray. Used a little bit of a paintbrush to put that on. I suspect there's probably an easier way of doing this, but clamp that on. And then to put the Corian in the wood, I used a 2-part epoxy. Mix that up. Now this was a bit of a pain to get onto this bit. There's got to be an easier way of doing this, and I'm sure you guys can kick around some ideas in the chat room on how I could do this better next time. And then I clamped that in there, and we set that overnight to dry, and came back the next day, and I fixed the jig up to the CNC machine so that I could make sure that both snack trays were in the same spot. So I just needed to zero the center off of one of those pucks, and then when I swapped out the trays, everything would line up where it needed to be. Now here we go. As you can see, there's the two examples. The top one is the raster, and the bottom one is the offset tooling. There's the offset tooling going on there in the preview. Then the raster. And because we were all safe behind the plexiglass and so on, when this happened, we weren't in any kind of danger. It just worked out well. And then you can see now this one came back with the raster and finished off really quite nicely as well. So definitely with this particular situation, I would have used the raster in the end if I had thought that through better. And there we have it. Pop those off. The next thing to do is to add a little teeny bit of finish to it. You can see I went a little deeper and a few pieces were missing there. The extra depth was because I didn't zero off very well, but it did work out in the end okay. I used a little bit of booze block on there. That's mainly used for chopping blocks so that it's sort of food safe. Wiped that on, let it sit for a little bit, and then wiped it off, and the finish turned out really, really nice in the end, I think. Anthony and some amazing photography there. Thank you, Anthony, for all that work. Okay, there you have it. That was me cutting that. Learned tons of stuff on there. And like I said, one of the things that I learned was that choosing the proper toolpath strategy when you're doing things is really, really important. And you want to make sure that you choose the right one for the job. Okay, that's really important. So if you choose to go ahead and want to cut these on your own, if you're new to VCarve inlays, I totally think that you should try this out. Go right and look at Mark's files and learn how he did it, and then maybe even go ahead and take it a bit further and use my files and go ahead and cut yourself a snack tray. If you don't, or maybe you use this inlay for something else like a cutting board or I don't know, whatever you use for the side of a stereo or the bottom of a trinket box, whatever it happens to be, please share it socially and tag us in it. If you put it in the Vectric forum, we'd love to see it as well. We'll see it there, obviously, but if you put it out there socially, then please tag us in it. Now, if you do go ahead and download this, you're going to get a pile of files. You're going to get 5 different tool paths. You're going to get the 2 that Mark made, and they are made up to work in VCarve Desktop or Pro, so you can run those. And if you want to go a step further and you happen to have a Spire, then you can go ahead and look at the snack tray male and female, and also the surfacing tool paths that I made up there. In there, of course, as always, is our PDF to show you how we made a little background on it, and also what you need for tools and so on to run our particular files. So there you have it. Now, Rebecca has done a great job socially on our Instagram feed, reaching out to some of our users out there that have much more experience with VCarve inlays than I do, and they have been submitting some tips. So yesterday's tip came from Mr. Elzinga, and I'm sorry, I know I pronounced that way wrong, and this was his tip.
Hi, I'm Sietse Elzinga, and my VCarve inlay tip is to do a profile cut around your inlay. Don't just cut them out of your board, but really do a profile cut, and that gives you the advantage that when you do the dry fit without glue, you can really look under the edge and see if everything fits right and that you don't have any gaps. So yeah, that's my tip.
Now that tip also would help with my problem with my choosing the right or choosing the offset tooling. Excuse me. If I had a different shape, then that wouldn't have happened, and I would have ended up being. I probably would have gone down the raster road in that case. But that's certainly in Mr. Elzinga's tip. You can see on the edge of that inside the dish is kind of hard. But if that was proud or resting on top of my project, then that's a perfect tip, and what a great tip. So the rest of the week, there will be more tips from seasoned inlayers on our Instagram feed. So go ahead over there, and please, if you haven't followed us there, please do. Yeah, take advantage of those great tips, and hopefully they'll they'll help demystify this a little bit more for you, okay? I want to take a minute now and thank Mark Lindsay for really stepping out of his comfort zone and trying this VCarve inlay thing and giving it a shot for us. We appreciate all the work that Mark did on it, and the files, like I said, there was nothing wrong with his files. They worked perfect, and I really appreciate that time that he spent. So, and I'll also be interested, Mark, here's a little challenge for you. Didn't tell you about this, but when you get a chance to get that CNC up and running again, I'd love to see you cut this and send us a picture of your finished part and any of the experience that you might have had in making that. Okay, that would be fantastic. Okay, Mark, thanks again. I really appreciate that a lot. Now, next month on March 16th, we're going to have another one of these, and we're going to have a special guest. His name is Tim Sway. You all know Tim Sway, I'm sure. Interesting guy, does a lot of upcycling, and he's got a really great project that I'm really super excited to share with you. There's all kinds of aspects of this that are interesting, and one that I think is going to be a part that you can make that's going to change the way you make other parts, other projects in the future. So next month, come on, same time, same place, tune in on March 16th, and I'll share with you his project. And again, we can take your comments and questions in the chat. Yeah, it's going to be great. I'm looking forward to it. So from all of us here at Vectric, we hope that you're still making stuff, hope that you're having lots of fun, and really, in all aspects of your life, every single one of them, we hope that you're being safe. Okay? Until next time, thanks again for stopping by. Bye-bye.